In 1962, a Nobel Prize is awarded to James Watson, Francis Crick, and Maurice Wilkins for their groundbreaking work on DNA. It is one of the greatest achievements in the history of science, often described as the key to unlocking the secret of life. A few years later, James Watson publishes his personal account of the discovery. In the Double Helix, this slim, best-selling book, he depicts a race to determine the structure of DNA and introduces a little-known scientist named Rosalind Franklin. Rosalind Franklin was born in London in 1920 into a family that achieved wealth through banking and publishing. They had a proud tradition of scholarship, philanthropy, and involvement in social causes. From an early age, Rosalind stands out. She enjoys memory games, and an aunt writes, "Rosalind is alarmingly clever. She spends all her time doing arithmetic for pleasure, and invariably gets her sums right." Her parents send her to St. Paul's Girls' School, which, despite its name, had no church affiliation. What it did have was a strong tradition of preparing girls for a career. Rosalind is anxious to do something useful with her life. She finishes a year early at St. Paul's and wins a scholarship to study physics and chemistry at Cambridge University.
In 1938, Rosalind arrives here at Newnham College, one of the women's colleges of Cambridge University. In her classes, she's introduced to the new subject of X-ray crystallography.
This technique can reveal the hidden atomic structure of matter in its crystalline form. Atoms are too small to see under light microscopes, so crystallographers shoot invisible X-rays at them, which then bounce off or diffract onto a detector such as film. By applying math to the diffraction pattern, it's possible to calculate the three-dimensional form of even the most complex molecules. Franklin is offered a position at King's College in London, a highly prestigious research center. She is hired by J.T. Randall, the director of the biophysics labs, to create an X-ray diffraction unit to investigate the structure of proteins. She accepts the offer, but writes to a friend, "To change the banks of the Seine for a cellar on the Strand seems to me quite insane." But as she is leaving Paris, she receives a letter from Randall, shifting her focus from proteins to the little understood substance called DNA. Rosalind Franklin is 30 years old as she unwittingly enters an undeclared race to unravel the secret of life. DNA was thought to consist of sugar and phosphates in long chains of some unknown shape. It also appeared to have just 4 other chemical ingredients called bases. But how could such a simple molecule be responsible for the diversity of all life on Earth? Some believed that discovering the structure of DNA would lead to an answer. That was Franklin's assignment when she arrives at King's College London in January 1951. Maurice Wilkins, a physicist fresh from the Manhattan Project, took some of the first X-ray diffraction images of DNA here. He had to improvise at every step to cope with the lab's antiquated technology. Franklin quickly adjusted to the physical limitations of the lab, but not to the segregated boys' club culture of King's College. To make matters worse, there was confusion over who was in charge, Franklin or Maurice Wilkins. At the time of her arrival, Wilkins was on holiday. While he was gone, his PhD student Raymond Gosling was put under Franklin's supervision. When Wilkins returned, he walked into a vastly improved lab, but it wasn't his anymore. He lost his lab and his PhD student, and Rosalind Franklin, whom he thought was going to be his assistant, turned out to be better trained and already working independently. When he checked in on her progress, he was rebuffed. The situation was inflamed by a basic personality clash. Franklin, articulate, passionate, and always up for a good debate, and Wilkins, soft-spoken, deliberate, and shy, just couldn't get along. Despite all the tensions of the lab, Franklin applied herself to the task with single-minded determination, setting her sights on solving the structure of DNA. But now, a new player was about to enter the game.
While Rosalind was setting up her new lab at King's College London, James Watson, much younger, 23 but with a PhD, had come to Europe because he wanted to study the gene, and he was convinced that the gene was the thing to study. This is going to be the secret of life.
Watson goes to a conference in Naples, where Wilkins shows one of his early fuzzy diffraction images of DNA. Watson tries to meet Wilkins and wrangle an invitation to work at King's College. Wilkins does not take the bait. But shortly after, Watson is invited to the Cavendish, a famous research lab at Cambridge University, headed by Nobel laureate Sir Lawrence Bragg. There, Watson is assigned an office with another physicist turned crystallographer, Francis Crick, an old friend of Wilkins. Crick and Watson immediately click. But an hour away at King's College, the negative atmosphere takes a new turn for the worse. Rosalind Franklin is given the sarcastic nickname that Watson will later popularize in the double helix, Rosie. Despite the hostile environment, within months of her arrival at King's, Franklin is producing amazing results. Franklin's discovery that there are two forms of DNA is perhaps the most crucial step toward the ultimate discovery of its structure. The A is a drier, more crystalline form of DNA and produces more detailed images. The B is wetter, and how DNA occurs in living cells. It produces a simpler image, but reveals a key clue to solving the structure of DNA. The X shape in the middle is the diffraction signature of a helix. The significance is not lost on Franklin. She notes it in scientific shorthand and, according to Klug, presents her discovery. In the audience that day is James Watson, sent by Crick to gather intelligence on Franklin's labors. Crick and Watson are planning to use a different approach to solving the structure of DNA, model building. Within a week, Watson and Crick invite the scientists from King's College to see their model.
So Rosalind just was terribly amused, and she never took prisoners anyway, so she was pretty sharp in her criticism of the model and explained in detail why it couldn't be correct, 1, 2, 3, and then we left.
The model of DNA touted by Watson and Crick is an embarrassing failure. Lawrence Bragg, the head of the Cavendish lab, is humiliated and forbids Watson and Crick to continue their model making.
It was a happy moment for Rosalind and me because it justified her interpretation that you could build models, but you couldn't prove which was the right one. And here they were, the model builders, hard at it, and they'd produced completely the wrong model.
To Franklin, the incident is an affirmation of her training, that experimentation and patient analysis of the data will reveal the answer. But what Franklin may not know is that her unpublished findings will continue to make their way to Watson and Crick. And they are getting there through the deputy director of her own lab, Morris Wilkins. But while Crick and Watson speculate, Franklin continues to analyze and collect new information. In May 1952, she sets up the X-ray diffractometer to take an image of the wetter form of DNA, the B. In May 1952, Franklin's perseverance and exacting techniques pay off, producing the sharpest image yet of the B form of DNA. She labels it Photo 51 and puts it aside while she continues her work on the A form. But around this time, Franklin will acquire another nickname, the Dark Lady. She is so unhappy at King's, she arranges to leave. She agrees to finish analyzing her data, write up her findings, and stay until the end of the year. In the midst of this transition, someone gives Photo 51 to Wilkins. Meanwhile, at the Cavendish, a new researcher moves into the lab with Watson and Crick. Peter Pauling, the son of the renowned guru of chemistry from Caltech, Linus Pauling. Only a year ago, Pauling had pioneered the same model building technique adopted by Watson and Crick. With little experimental data, Pauling had come up with a structure for long stretches of proteins, a single-stranded helix. Now, Pauling sends his son a paper in which he proposes a structure for DNA. Pauling makes some of the same mistakes that Watson and Crick had made on their first model, a three-stranded helix with the bases on the outside. But Pauling's mistake will be discovered as soon as he publishes. Watson knows that if Pauling gets access to Rosalind Franklin's data, he could quickly come up with a correct model. Now, the race begins in earnest. Watson estimates he and Crick have 6 weeks to solve the problem. Around the time Franklin gives her last presentation at King's College, Jim Watson shows up in her office. He tries to show her Pauling's paper, perhaps to convince her that Pauling will beat them to solve the structure of DNA if she doesn't pool her data with him and Crick. And according to Watson's account, he implies that she is incompetent in interpreting X-ray pictures.
And as he tells us in the double helix, she began to advance toward me. And he said, fearing that in her hot anger she might strike me, I retreated, which is actually absurd. She was almost half his size.
Watson then reports that he runs into Morris Wilkins. Wilkins shows Watson Photo 51. My mouth fell open and my pulse began to race, Watson says in the double helix. It is the clear X pattern, the signature of a helix, that ignites his excitement. But there's more. The number of lines in the photo shows that each twist of the helix has 10 units, or molecular building blocks, and the dimensions of the image correspond to a helix of 34 angstroms per turn. Wilkins gives this crucial information to Watson. Watson sketches Photo 51 on his newspaper and reports to Crick. Based on Franklin's data, Crick and Watson go to Lawrence Bragg, the head of the Cavendish lab, and he gives them permission once again to build a model. They begin on February 4th, 1953.
Then they had another idea. They knew that data from all of King's biophysics unit, including Rosalind's work, was published in a report for the Medical Research Council.
In the MRC report, Franklin places DNA in a class of molecules with a certain type of symmetry, as these simple drawings in her notebook illustrate. The implications of that symmetry would be obvious to an expert like Francis Crick. 2 strands each with the sugars and phosphates running in different directions, an anti-parallel double helix. But where do the bases go? On the outside, as Watson and Crick depicted in their first model, or the inside, as Franklin had told them? There were 2 important clues. A few years earlier, a British scientist, William Asbury, theorized that the 4 bases, adenine, thymine, guanine, and cytosine, would be stacked like pennies. And at Columbia University, Erwin Chargaff discovered that DNA always contains equal amounts of adenine and thymine, as well as equal amounts of guanine and cytosine. At first, Watson thought that the bases must be paired like with like, A with A, G with G, and so on. But an office mate, Jerry Donahue, shows him that he's using the wrong chemical forms. With the right forms, Watson then makes a giant leap. He finds he can fit the bases into the helix measured by Franklin if he pairs A with T and G with C. Arranged this way, the bases form the connecting rungs in a twisting ladder on the inside of a double helix. It is Rosalind Franklin's experimental framework, a collection of evidence painstakingly accumulated over 2 years, that guides Watson and Crick to solve the structure of DNA. And in another eureka moment, the structure rewards them with the immediate realization of how DNA replicates. Unzipping the helix produces 2 templates to create 2 new helices, each identical to the original. DNA isn't just a molecule, it's the blueprint for life. In one of the most famous understatements in science, Watson and Crick write, "It has not escaped our notice that the specific pairing we have postulated immediately suggests a possible copying mechanism for the genetic material." The day was Saturday, February 28, 1953. Now that they have discovered the secret of life, they have another problem to solve. How are they going to prove it? Once again, they need Franklin. She travels to Cambridge to review the model.
And Watson writes in his book that her immediate acceptance of the model amazed me. But she understood immediately that the model was correct. What she perhaps didn't know is how much of her data they had known in order to build that model.
Rosalind Franklin could be said to be Watson and Crick's unknowing and unrecognized collaborator. By the time the articles appeared in Nature on April 25, 1953, Franklin had taken her new position at Birkbeck College in London. In her 5th-floor office under a leaky skylight, she often left an umbrella open on her desk to protect her papers. She headed the Virus Research Lab from 1953 to 1958 and thrived in Birkbeck's collegial atmosphere, much like her beloved laboratoire in Paris. Here, she made what she called her greatest discovery, working out the complex structure of a virus and locating its infectious element. She collaborated with Aaron Klug, who later wins a Nobel Prize. Franklin's virus work secured her international reputation and brought many invitations to speak in the United States. In 1956, she celebrated her 36th birthday while visiting universities in California and climbed Mount Whitney, one of the highest peaks in North America. But near the end of her trip, Franklin was suffering from severe abdominal pains. On her return to England, she was diagnosed with cancer. There is speculation that her work with X-rays may have triggered the disease. Her epitaph reads, "Scientist. Her research and discoveries on viruses remain of lasting benefit to mankind." She died April 16, 1958. That same day, the London Times carried an article acclaiming her virus model, which was unveiled at the Brussels World Fair. She went to the grave, never knowing how much Watson and Crick had relied on her work to make their great discovery. Or if she knew, she didn't care. In 1962, James Watson, Francis Crick, and Maurice Wilkins won the Nobel Prize for their discovery of the structure of DNA. Franklin's name receives no mention, save a passing reference by Wilkins. Her crucial contribution to their work becomes a footnote in scientific history. Franklin is now receiving some long overdue recognition, plaques where she lived and worked, and recently, Britain's Royal Society created the Rosalind Franklin Award to support women in science. Those who admire Franklin take solace in her uncompromising dedication. For Rosalind Franklin, the joy of science was in the work itself, and its ultimate reward, the betterment of humankind.
On Nova's website, find out why Rosalind Franklin's Photo 51 holds so many clues to the structure of DNA at pbs.org. For America Online keyword, PBS. The Secret of Photo 51 video and the book Rosalind Franklin, The Dark Lady of DNA are available from WGBH Boston Video. To place an order, please call 1-800-255-9424. Nova is a production of WGBH Boston. Major funding for Nova is provided by the Park Foundation, dedicated to education and quality television.
Science. It's given us the framework to help make wireless communications clear. Sprint is proud to support Nova.
We see an explorer. At Microsoft, your potential inspires us to create software that helps you reach it. Your potential, our passion.
And by the Corporation for Public Broadcasting, and by contributions to your PBS station from viewers like you. Thank you.
I am PBS.
Put the genie back in the bottle. It's a radical finding.